In this video we're going to talk about the algebraic properties of the logarithm. Here I've pre-sketched a graph for us here to save a little bit of time. Y equals b to the x, that is y equals 3 to the x, y equals 5 to the x. Any of them are going to have this kind of general shape here, and they're going to pass through the origin there at 1. Okay? And what we want to look at, let's see, let's take for example, let's take some number m here. We know that for any number m, they're bigger than 1, that there's going to be some x1 where b to the x1 equals m. Okay? So what that immediately tells me is that the log base b of m equals x1. That is b raised to the x1. These two are they're saying the exact same thing. Okay? We're going to need that several times. And let's take a second number. Let's say n. And we go over here and we see some x2 there, some other x that I raised b to get in. That is b raised to the x2 equals n. Well, that is the same as saying that the log base b of n equals x2. That is b raised to the x2 equals n. Okay? And let me copy this page a few times because I'm going to need this several times. So let's say duplicate page, edit, duplicate page, edit, duplicate page. We got several times. So now let's look at a couple of these problems here. Let's look at I'm going to derive the properties. Let's look at b, let's say b raised to the x1 times b raised to the x2, right? So we see clear that's m times n. But by our properties of exponents, we know that this becomes b raised to the x1 plus x2 equals mn. But that immediately tells me that the log base b of m times n equals x1 plus x2. But if we see over here, x1 is log base b of m and x2 is log base b of n. This implies our property here that the log base b of m times n, let me make a little room for that, make it bigger. So that is the log base b of m times n equals x1, which is log base b of m, plus x2, which is log base b of n. Okay? So that's your first algebraic property of logarithms there. Let's go to the next one. What's the next one? The division. So let's look at this one. So we're going to look at b to the x1 divided by b to the x2. So that's going to be m divided by n. Okay? But we know by our properties of logarithms, here we get b to the x1 minus x2 equals m over n. Okay? Now that tells me that immediately tells me that the log base b of m over n equals x1 minus x2. So that is x1 log base b of m minus x2 log base b of n. So we have our second property here, the log base b of m over n equals x1, which is log base b of m minus x2 log base b of n. So that is our second property there. What's the next one going to be? As I flip through the page here, log base b of 1 over y. So we have log base b of 1 over y. So let's look at, and we're going to consider 1 over m. So let's say b to the m, b to the x1 equals m, right? And b, if I raise both sides to a negative power, b to the x1 raised to negative 1 equals m raised to negative 1. I get b to the negative x1 equals 1 over m. That tells me that the log base b of 1 over m equals a negative x1. But that immediately tells me that what is x1 log base b of m. So this gives me that the log base b of 1 over m equals a negative x1. Well, x1 is log base b of m. Log base b of m. Okay, and let's write this a different way. Log base b of 1 over m is m to the negative 1 equals a negative log base b of m. So what they're really saying here is that you can bring that negative exponent down in front. Okay, so that is that one. Let me see how I'm looking on time. 7 minutes 10 seconds. So I have time to do one more, then I'll close this video up and do another one. Let's see here. The logarithm of a power. Let's see here. We got the log base b of, we're looking at something like the log base b of m to the t. Okay? So let's look at b raised to the x1 equals m, right? So b raised to the x1, and both sides, you can do anything you want to a math equation as long as you do it to both sides, equals m to the t. And so b, that is b raised to the x1 t equals m to the t. And so that immediately tells me that the log, this implies that the log base b of m to the t equals t times x1, but we see over here x1 is log base b of m. So this gives me that the official algebraic property here is log base b of mt equals t times x1, which is log base b of m. Again, this is the same as the last one, so more general. We can bring that exponent out to the, out in front. Yes, and let's end it with that one. And we have a couple more properties here. Is that the last power? Is that the last property? Oh, okay, cool. That's the last property that I'm seeing here, section 3.3. Okay, so that's going to conclude these algebraic properties of the logarithm. Hope this helps you with some intuition as to why these properties are what they are, and they're not just some type of smoke and mirrors. They actually, you can deduce them and make them make sense. Okay, and I advise you to work through these. It's good for your brain.